Hello everyone, welcome back to the part 3 of building movie list TMDb app with SwiftUI. In this video, we're going to build the movie list screen that shows the image of the movies within horizontal carousel sections. Along the way, we're going to build image loader observable object to fetch images from the network and cache it with NS cache in memory cache. Also, we'll create the movie list state observable object to fetch movie list data given an endpoint, such as now playing or upcoming movies. So, without further ado, let's start coding and build our app. Continuing from part 2, where we have built the movie model and movie service TMDb API client, now let me open the preview of the UI we'll create. Let's start building the movie backdrop card. It has an image with 16 by 9 aspect ratio and a text inside a vertical stack. Create a new folder, name views from the project navigator. Then, create a new SwiftUI file named movie backdrop card.swift. Before we implement this view, we need to create image loader observable object to fetch image from the network. So our view can subscribe and update when the image has been downloaded successfully. From the project navigator, create a new folder named bindings. Then create a new Swift file named image loader. Let's import UIKit as we are going to store UI image as the property inside our class. To cache the data locally, we use NS cache. This class is similar to a dictionary, but it has a built-in mechanism to automatically release objects from the memory if the system memories are low. We also store this as a global variable. We declare image loader class and make it conforms to observable protocol. We also declare image and its loading properties using publish property wrapper. With this in place, SwiftUI view will be able to observe and update the view whenever one of the property is assigned with new value. We declare the image cache property and assign it using the global NSCache variable that we declared earlier. Let's fix the build issue by importing SwiftUI instead of Foundation. Let's create the load image method that accepts an image URL as a parameter. First, we get the absolute string of the URL and assign it in a variable. This acts as the key to retrieve the image from the cache. If the image exists, we assign it to the image property and return. To download the image asynchronously, I'm going to switch to default background thread using dispatch queue. Make sure to mark self as weak to avoid return cycle. Then, we can use the blocking data initializer that accepts an URL to download the image. If no error is thrown, we initialize UI image using the data in a guard statement. If success, we cache the image using the URL text as the key. At last, we switch back to the main thread and update the image property. Let's go back to movie backdrop card file and start implementing the class. The first property is the movie instance. The second one is the image loader observable object. We need to add observe object property wrapper for the view to receive the notifications when the published properties are updated. To display image and text vertically, we can use vstack to wrap those views. We'll set the alignment as leading. Let's use zstack as the container for the image. Then we declare the text using the movie.title as the value. We use a rectangle shape as the placeholder when image is null. We set the fill color as black with 0.3 as the opacity value. Next, we use if condition to check if the image value exists. If yes, we use the image view passing the UI image to the initializer. To make the image resize, we need to use the resizable modifier. Let's use the live preview to see the results. We need to pass the stop movie in the preview. As you can see, the C-stack fill all the remaining space within the view. We can limit this by either using a frame modifier or an aspect ratio modifier. In our case, as the backdrop image is using 16 by 9 aspect ratio, we need to use aspect ratio modifier and pass width as the content mode. Let's also pass corner radius as 8 to make the corner a bit rounded and set the shadow radius to 4. To download the image from the network, we need to invoke the image loader's load image method and pass the image URL. We can use the onAppear modifier to fetch the image when the view appears on the screen. As we only have the backdrop path string, we need to create a computed property to generate the backdrop URL. To generate the backdrop URL, we need to prefix it with image.tmdb.org/t/p/w500. Then we can append the backdrop path string as the last path. Let's update the invocation by passing the backdrop URL. Make sure to tap on the arrow button and build the project. You should be able to see the results of the download image in the live preview. Let's move on to the next part to build the movie backdrop carousel. So we can put the backdrop card view in a horizontal scroll view. From the project navigator, in the views folder, create a new SwiftUI file named movie backdrop carousel view.swift. The first property is the title of the section. The second one is the array of movie instances. Make sure to pass the properties in the preview initializer. In this case, we can just pass a hard-coded string and stop movies array. Let's implement the body of the view. We'll use a vstack as the container view. We also set the alignment to leading and the spacing to 0. At the top, we show the text containing the title. Using the modifiers, we set the font using title style, font weight to bold, and add a default horizontal padding. Below the text, we have the scroll view with the axis set to horizontal. We also set the show indicators as false to hide it when scrolling. To make a carousel in a scroll view, we need to use hstack. Set the alignment to top and spacing to 16. Inside, we can use for each passing the movies array. Let's make movie model conforms to identifiable. By using identifiable protocol, SwiftUI will use the ID property to diff the value when the array changes. In the closure, we initialize movie backdrop card by passing the movie instance and return it. Also, we add padding for leading item if it is the first item in the array, and the padding for trailing if it is the last item in the array. Also, I just found out after the recording of this video that instead of doing this, We can also add the horizontal padding in the edge tag level. You can use that approach as it's more cleaner without additional logic. Let's build and run the live preview. Looks like the image is overflowing the container view. To fix this, we need to use the frame modifier and constrain the width to 272 and the height to 200. The result still looks pretty weird. We need to make the text line consistent. In this case, we have to limit the number of the lines to only one. So let's go back to the movie backdrop card and add a line limit modifier and pass the value as 1. The result is looking pretty good. Let's try to scroll the carousel in a horizontal direction to make sure it works correctly. Let's move on to the next part. In this part, we'll be focusing on building the movie poster card that shows an image using portrait aspect ratio. Create a new SwiftUI file named movie poster card in the views folder. Let's add the movie as the instance property and the image loader observable object using observe object property wrapper. Don't forget to inject the stop movie in the preview. Just like the backdrop card, we use zstack as the container view. In this case, we use an if condition to check if the image is not nil. Then, if yes, we declare the image view. Add resizable modifier, set the content mode to fit. Also, we set the corner radius to 8 and shadow to 4. If image is nil, we choose a rectangle placeholder with gray color and opacity set to 0.3. Also, on top of that, we show a text containing the title of the movie with central alignment in case the image download fails. At last, using the frame modifier on C-stack, we constrain the width to 204 and height to 306. Make sure to add on appear modifier. Inside the closure, we invoke the image loader's image method, passing the poster URL. But before that, we need to create a computed property to generate the URL using the poster path text property, just like the approach we use to generate the backdrop URL. Let's run the live preview and see the results. Okay, looks good. Let's move on to show the posters in the carousel. Create a new file named movie poster carousel view.swift in the views folder. Declare the title string and movies array as the instance properties. At last, stop the values in the preview. We use vstack to stack the title and poster card vertically. Set the vstack alignment to leading and spacing to 16. At the top, we have text containing the title, font with the title style, and the font weight as bold. And we also add a horizontal padding in both sides. Below that, we declare a scroll view with horizontal axis and set the shows indicator as false. Then, we use horizontal stack with alignment set to top and spacing of 16. Using for each, we pass the array of movies. In the closure, we initialize the movie poster card passing the movie. At last, we add leading padding for the first item and trailing padding for the last item. Let's run the live preview and see the results. Wow, looks nice. With all the views in place, we can move to build the movie list screen. Create a new SwiftUI file named movielistView.swift. To fetch the movie list given an endpoint from TMDb API, we need to create an observable object. Create a new Swift file named movie list state in bindings folder. Let's import SwiftUI at the top. Then declare movie list state class and conforms to observable object protocol. We have three published properties as the state of fetching the data. Array of movies is loading boolean, an error, which is an NS error. Let's also declare the movie service interface and store it in a constant. In the initializer, we inject the service with movie store as the default value. We declare load movies method with one parameter, which is the movie list endpoint. Before fetching the data, we reset all the properties and then invoke movie service fetch movies, passing the endpoint. In the closure, make sure to use weak on self to avoid memory leak, and set its loading to false. Then we can use switch statement on the result enum. If success, we retrieve the response associated value and access the result property and then assign it to the movies property. If fail, we assign the error associated value to the error property. When fetching the movie data, we want to show some kind of visual feedback to the user. So, let's build this component. Create a new file named activityIndicatorView.swift inside a UIKit views folder. In UIKit, we can use UI activity indicator view for this purpose. While in SwiftUI, Apple doesn't provide this kind of view. To solve this, Apple provides UI view representable protocol where we can use it to show UIKit view in a SwiftUI view. Declare a new struct named activityIndicatorView that conforms to UI view representable. There are two required methods to implement. The first one is the makeUIView method that expects us to return an UI view. This protocol is using associated type generic. In this case, we replace the placeholder with UI activity indicator view. In the body, we initialize the view passing large as the indicator style. Then, we invoke start animating, then return the view. The other method is update UI view method. In our case, we can leave this as empty. Let's move on to the next component, where we'll use the activity indicator view in. Create a new file named loadingview.swift. The purpose of this view is to act as a container for the activity indicator view when we load the data from the network and if an error occurs. We have two state properties, is loading and error. Also, one optional property closure that we call retroaction. In the body implementation, we use the group view. With this view, we can return a different view depending on the conditional condition. If its loading is true, we return the activity indicator view inside a hashtag between a spacer to center it. If error is not nil, we show the error copy in a vstack. If the retry closure exists, we add a retry button that invokes the closure given by the parent view. Let's see how this works later when we build the movie list view. Let's go back to the movie list view file and begin implementing the view. The approach we are going to use here is to fetch the movie list endpoint independent of each other. In this case, we have 4 movie list endpoints. So, let's declare 4 observed object properties for each of the endpoint. Now playing, upcoming, popular, and top rated. In the body, we'll use a navigation view as the root view because we are going to push the movie detail screen later on. Then, we declare list view as the vertical scroll view for the carousels. For each of the movie list state, we are going to check if the state movies array properties exist. If exist, we're going to display the carousel view. Else, we display the loading view we just built in the previous section. For the no playing section, we use movie poster carousel view to show the poster image. For the rest of the sections, we use movie backdrop carousel view to show the backdrop image. In the loading view retry closure, we need to pass the correct endpoint to refresh the data in case of retrying an error. We set the navigation bar title as the movie DB. Finally, we need to add on appear modifier on the navigation view so we can fetch the data when the navigation screen appears on the screen. Let's try to run the app in the live preview. Awesome! The movie data is successfully displayed on the screen, but there are two things we can improve. First, the horizontal padding on the carousel looks odd. Second one, we have to remove the line separator for each row. When using a list view, we can use the list row insets modifier to customize the inset in 4 directions. In this case, we want to set the leading and trailing to 0, so the carousel can scroll from edge to edge. We also want to add some insets for the bottom and top padding, so there's a vertical white spacing between sections. Currently in SwiftUI, there is no API that we can use to remove the separator from the list. But there's a little hack that I found where we can use UI table view appearance proxy and set the separator style to none, so we can remove the separator. For the reminder, this will remove the separator for all the lists in the SwiftUI app. In our case, this is the behavior that we want. That's it for part 3 of the series. To summarize, we have created several views: movie backdrop card, movie poster card, movie carousel scroll view, and the movie list view. Also, we create an activity indicator view using UI view representable. For managing data loading state, we have created image loader and the movie list state. So, until the next one, let's keep the lifelong learning goes on, guys. Bye!